Okay, with question 3, we've got our cute little bear here, although he's looking a little bit grumpy. First thing we notice is that there's no base number there, or original. Okay, so we read the question. We've got 6 pairs of bears, rhyming pairs of bears, in 1998. So that would mean, 6 pairs, I'm assuming 2 in a pair. So B0 is going to be 12 bears. Okay, now with part B, find the expected bear population in 2018. So check T is definitely in years. So from 2018 to 1998, that's going to be 20 years. So once again, we're going to use our lovely notation, or correct notation, we should say. So B of 20, that's going to be 12 times 1.13 to the 20. Now, if you had got that wrong and you'd put 6 as your original instead of 12 and you'd carried on, if you'd put your proper notation, you probably wouldn't lose that many marks. So that's why it's very important to put your thinking down on paper. So into the calculator we go. And this is where we have our debate, 138.27, right? I would round that to 138 bears. Right, even if you had 138.5 or 0.6, what would you do, right? Is there technically, do we round up, do we round down? Always put your figure and then go approximately equal to. Right, on to C. So probably not really a exponential question, it's more of a percentage question. Okay, so percentage increase in population, that's now just a little bit of a reminder. So percentage increase or percentage change, just pop this in your knowledge bank. It's basically the change divided by the original times 100, and you'll get your percentage change. Okay, so let's have a look. I guess we could do it individually. I'm just going to do it all in one hit, so I use my calculator once. So that would mean I'm going to look at B20, when T is 20, because that's your 2018, minus B10 all over B10, and I'll times that by 100 to get my percentage. Okay, so B10 will be 12 times 1.13, and I'll just fill this out. That's to the 20 minus 12 times 1.3 to the 10. You just don't have to watch me write it. Divide by the original, which we said, B of 10, which is 12 times 1.13 to the 10, times 100. And all that we have to do is pop that into our calculator. Okay, so 12 times 1.13 to the 20 minus 12 times 1.13 to the 10 all over, oops, missed a 12 up there, didn't I? 1.13 to the 10, and again you can just see why it's really important that you write everything down before you put it in your calculator, because if I had not, if I'd left that as an 11 instead of a 12, going to be in strife. So 239% or 239.5% is up to you. If they've got something different in your answers, oops, then that's probably going to be that they didn't do exactly as we did, that they might have rounded off, so they might have used 138 bears instead of 138 point whatever we got, but you get the gist. Now D, so how long will it take to think? So we're actually finding the time, and because that is a power, we either are going to do it using logarithms, which will come in a couple of next week, or use technology, or get it to the same base. So we'll just pop that down first. So how long will it take the population to reach 200? So what we're actually solving is 200 equals 12 times 1.13 to the T. Now we can get rid of the times 12, but clearly we can see it's not going to allow us to get anything to the same base. So, like we were doing in a previous exercise when you might have had 2 to the x equals 16, we can write this as the same base. We can't do that here clearly. So it's definitely a calculator problem. You could graph it, or you could go into solve n. So we did the graphing last time. Let's stay in our normal calculator and we'll go to calc, solve n. We've got 200 equals 12 times 1.13 to the x. Let's mix it up a little bit. Yes, we can have more than one. So 23 years. Let's confirm that. Have a look how we would do it using our graph. So we're going to go into our normal main menu. We will type in 12 times 1.13 to the x. Okay, because it's always good to be able to do that. Now let's see, 30 years. Well, we went up to 20, so we might as well stick with that. But obviously our scale, our scale's not too bad. How do we get equals 200? You can do a y calc, x calc. I like to put my 200 in here so I can see, and then g solve, intersect. And we get the same answer. Okay, get rid of that, go back, and we could go g solve. This time it's not a y calc, it's an x calc. So when y is 200, lo and behold, same answer. So be confident using technology.